Right, folks, my laptop makes it 3 o'clock, so I will make a start. As ever, I was looking over my slides a little while ago, re-familiarizing myself because I will shamelessly say these are mostly slides that I've given before, I think most recently in NDC London last year. And I looked and thought, there's no way this is an hour's material, which I always do, and then I always run over. So we'll see. It's good to see so many people here who are clearly fascinated with dates and times. Or alternatively, this is a clear statement of my privilege, and next time I will just go all out and have a talk of let's all come together and smash the patriarchy, and just see if I can get the same kind of crowd. Anyway, I want to be really, really clear about what this talk is about. And the secret is, you already know it because it's kind of in the title. But I have this slide many, many, many times. And I mean many times. And before the end of the session, I'm going to get you all to actually say it. Because what I never want to hear again is, oh, just dates and time zones are too hard, so I'll kind of just fudge it and not worry about it. The entire point of this talk is that you can manage it. I will be talking you through my way of thinking about dates and times. It's not the only way of thinking about it, but it kind of fits in nicely. And fairly obviously, it's the one that I've built into my .NET date and time library, Noda Time. Out of interest, how many of you are .NET developers? OK. And how many not .NET developers? OK. But it's fine, because this isn't a Noda Time talk. I will talk in terms of Noda Time types, but I'll explain what they are. And these days, most platforms have a decent date and time library, but it may well not be the one that's built into the platform. But the point is that I will go through the concepts. You will forget them, and that's fine, because you learning the concepts is not the point of the talk. If showing you the concepts helps persuade you that they are learnable, then that's fine. You've got so many great messages to take away from so many great speakers this week that there's no way you're going to come away with a crystal clear idea of date and time that will stick. What I hope will stick is this slide, so that next time you're working with date and time, not facing a date time problem, don't let it get that far, but next time you're doing anything with dates and times, you'll think, OK, now's the time. I will just dedicate a morning or dedicate an afternoon to finding out about date time things. And you could rewatch this talk and follow along the concepts. You could read the Noda Time user guide, which, again, is Noda Time centric, but it can all be applied elsewhere. It can be applied with the .NET date time and date time offset, should you wish. For the most part, it's just less pleasant. But the point is, you will be able to do it. So you then start thinking carefully, and it will take you longer to write your code to start with, and then you won't have all those bugs that we're all aware happen. So this is kind of what we're going to do. I'll skip through that. I will say what we're not going to talk about. Noda Time in particular does not deal with relativity. It does not deal with leap seconds. It does not deal with multiple alternate clock representations. It deals with multiple calendars, which I'll come on to. But these are things that I believe are sufficiently niche that we don't need them in 99.9% of programming. Some people do need them. If you're writing code for a GPS satellite, then you're probably not using Noda Time, and you probably know what you're doing. It's sufficiently specialist, you're fine. I should also update this slide at some point, because I've had at least a few people ask me on Twitter whether Noda Time is going to handle Martian calendars. No. I have good friends who are involved in the standardization of a new JavaScript date and time library, as part of JavaScript itself, and they work on Moment.js at other times. And there was a serious suggestion that, well, we've had the current JavaScript date library for 20 years, so the new one should last at least 20 years as well. And maybe we'll have colonized Mars by then, so maybe we should bake it in right now. It's like, no. Like, you are making life harder for everyone else on the planet for the sake of the very, very few people who might want that. So Yeah, this is the typical reaction. And yeah, this is the quality of slide drawing to expect. I was in Jennifer's talk earlier on, and it had fantastic memes and GIFs and stuff. And this is what you get with me, I'm afraid. Sorry. But the point is, it is all feasible, and I want you to feel calm. That said, I will tell you a few horror stories, and that's fine, most of which you won't need to deal with because they're well in the past. And I will highlight some things that are still difficult, and that most code will probably still ignore. But at least you'll know that you're ignoring it and leaving that problem for yourself. So just in case you'd already forgotten, you can learn this stuff. It is feasible. Another talk about text and numbers and dates and times of humanity epic fail, how people have screwed up everything, basically. I know a bit about Unicode, and I know it's enough to scare me. I know bits about floating point representations, and they kind of scare me too. And my point is, at least with date and time, it looks scary. It really doesn't have to be. OK, so we will talk through some concepts. And if you've come from Java, sort of pre-Noda Time and pre-JSR 3.10 Java.time, or if you've come from just plain .NET, there may seem to be an awful lot of concepts here. And there's a good reason for that, in the same way that if someone said, I've got this new programming language, and it's only got one numeric type, it's got floating points. We would never put up with a language like that for 20 years, would we, JavaScript? But it would be generally recognized to be a bit of a problem. And dates and times are far more varied, in fact, than just numbers. So this next slide is a list of concepts that we have in Noda Time. And this was Noda Time 2.1, probably. I could add annual date and offset time, but they're kind of niche types, and you probably don't need to care about them. And you could probably get away with thinking about them in terms of these anyway. So, what is time? I want you to start thinking for yourself, and I can't do this for you, about where you use dates and times, anything chronological, in your code base. So I can give you some examples. Your log messages probably have timestamps of some kind. And you may have database records with timestamps of when things were created. And if you do anything that is scheduling, you probably store some dates and times that users have entered. OK, I want you to keep as many of those concrete examples in your head as you can while we go through things. And then you can think, oh, yeah, that's what this one is, as I showed different examples. So the first sort of most fundamental idea, and it's fundamental in terms of there are no humans involved, because things get tricky basically when people get involved, is the instant. An instant in time is something that is globally recognized, and this is where not dealing with relativity comes in. So if I click my finger and I'm on a phone call with someone and they have an infinitely fast phone connection, then we can agree the instant at which that click happens, regardless of where they are and how fast they're moving and all kinds of relativity stuff. So an instant in time has no concept of years, months, days, because I could be talking to someone who uses a completely different calendar system and is in a different time zone, and it's all impossible. But an instant, the representation internally in Noda Time and in almost everything is there's some kind of epoch. So we usually use, or Unix folks always use the Unix epoch, which is January the 1st, 1970, midnight UTC, not midnight at Greenwich in 1970. I'll come on to that later on. There will be certain amounts of trivia here just to scare you. But that's the Unix epoch. .NET uses 1 AD, again, at January the 1st, midnight. And that's a perfectly good epoch. It doesn't matter at all. because you can convert between different representations trivially, so long as they have the same level of precision. Noda Time now uses a precision of nanoseconds, which is becoming sort of a reasonably industry standard. It's fine-grained enough, and it's feasible enough. As you start getting into picoseconds or whatever, it starts getting a bit expensive in terms of storage and things. So we use nanoseconds, and anything else that uses nanoseconds, regardless of which epoch they're talking about, we could convert. And obviously, there are limits to how far back and how far forward you can go. And chances are, if you're writing business code, you just will not care. Okay? Unless you are storing dates beyond year 9999 or 9998 and years earlier than, well, earlier than 1 AD could well be a problem in some cases, and certainly is in .NET. So it's worth being aware of the precision of the systems you're using and the range of values in the system you're using. But you probably look that up once and say, yep, that's fine. Don't care anymore. But the important thing is to understand that an instant has no calendar system, no time zone. Everyone can agree on it. This may be an appropriate representation to at least think of your data in for log entries. There are other options. This is sort of the purest idea for timestamps of all descriptions. When something happens is an instant. You may choose to store some more information as well, which I'll come on to. But this would be a good default first point. Right, so if we've got an instant, that's fine. We can also have 2 instants in time. And if you're going to have 2 instants, then you can work out the duration between them. So durations are time spans in .NET. They really are absolutely equivalent concepts. And a duration has no concept of where it started or finished. So this duration here, assuming it really is the same length of line, and stupidly I didn't just copy and paste, because then it would actually have been the same length of line. But if those two are the same length, then they are equal durations. Compare that with an interval, where an interval is a start and an end. So it has a duration implicitly, and frankly, if you're building your own date and time library, which I half recommend and half don't, it's probably a follow-on side project to Chris Bacon's Write Your Own CLI. But you could represent this as a start point and a duration, or a start point and an end point, and they're all isomorphic. You can get it from any 2 bits of that information, you can get at the third. It's fine. What we still don't have is any notion of years, months, and days, or any notion of time zones. So an interval could be, my system was down between this instant and this instant. How long was it down for? It was down for this duration of time. That duration of time will not be 1 month. 1 month is not a duration. 1 second is a duration, or 30 24-hour days is a duration. Whether you count 1 day as a duration or not is kind of, it's up for grabs. You can decide whether in your terminology you will treat a day equals 24 hours. It comes in interesting when time zones are involved. Okay, everyone happy so far? Good? Thank you. Yes, I do like a responsive audience. So just as a reminder, you can do all of this stuff. Is anyone here feeling I'm already out of my depth? I cannot understand instants, intervals, and durations. Okay? I do sometimes give talks where the idea is to tongue-in-cheek make it look like I'm really smart and show you loads of code to blow your mind. This is not one of those talks. Nothing here is terribly hard, which means if you don't understand something, that's because I've screwed up, and the best thing you could do for everyone in the room is shout out that I've screwed up in the form of, hey, I don't understand, why doesn't this work, or whatever, okay? It really is simple. My fault if you don't get it. Okay, next up, and you can tell this was given in January 2017, is calendar systems. Now, calendar systems are a way of human beings screwing with programmers. Calendar systems are entirely artificial. They are probably the aspect of human life where religion affects coding the most. Because almost every, I'm not kidding, almost every calendar system you come into contact with is started in some religious form or other. So, we've got the Gregorian calendar system and the Julian calendar system. Pope Gregory, Pope Julius. Yes. Sorry, not Pope for the Julius one. But the Gregorian calendar system is from Pope Gregory. And if you look at the epoch in a GUID, the timestamp-based system, the epoch is when the Gregorian calendar started. So it's deeply rooted in the Catholic Church. Okay, every time you're using a GUID, it's related to the Catholic Church. It is the place where religion and code come together. You've probably heard, how many of you have heard of the Julian calendar and Gregorian calendar before? Okay, keep your hands up if you could tell me the difference between them, and I promise I won't ask you. But if you think you know the difference. Okay, relatively few. It's really easy. The Julian calendar system has easier leap years. Okay, Julian calendar system, every 4 years is a leap year. In the Gregorian calendar system, that's true apart from when it's also a multiple of 100. So 1900, and it is true again if it's a multiple of 400. So 1900, not a leap year in the Gregorian calendar system, is in the Julian. 2000, leap year in both. So basically you can remove a couple of rules if you're building a Julian calendar. Hardly anyone uses Julian calendars apart from this odd idea of a Julian day number, which is sort of a way of going back to instant, but instead of, I've lost it. It takes an epoch that's a very, very long time ago and gives elapsed time in a floating point number of days. And it's called the Julian day for reasons that remain mysterious to me, other than I think the epoch is represented in the Julian calendar system, but could be represented in any other calendar system. Any instant in time, once you've given it a time zone, can be represented in any calendar if you treat it as a proleptic calendar. You don't need to know the proleptic, it just means sort of going back in time. The Gregorian calendar started at different points in different places in time, but we tend to think about it as going back, why bother having the idea of, okay, you're dealing with the date, January the 1st, 1600. Is that in Britain or in Sweden or in Norway? Because it'll give you different results for when things are. That's not a good idea. In fact, for 1600 it wouldn't. But calendar systems, various different ways. I've mentioned 2 of them. There are multiple other ones. There are various Islamic calendars, and that gets complicated in whole different ways. Someone's asking me to implement the Hindu, or one of the Hindu calendar systems at the moment. I got a bit of a surprise when I was shortly about to release Noda Time 2.0, because someone asked me to implement a new calendar system called the Wondrous or Baha'i calendar system. And my internal representation of things in Noda Time is that you have a date and it's got a year, month, and a day, and I like to be compact, so I store the month in 4 bits, because 16 months is going to be enough for everyone, right? The Baha'i calendar has 19 months. Okay, that's fine, I'll borrow a bit from somewhere else, and then we're good, right? Oh, well, yeah, sort of. It's got 19 months of 19 days, and then every year there are a few days that aren't in a month. Good luck with that. So, we fudge it and we represent it slightly reasonably, and people who want to use that calendar system can have something on top that sort of gives them a nullable int for the month of year or whatever. So, if you ignore time zones, you can imagine that timeline that we've had before and break it up into years. Again, ignore time zones. Break it up into years, break each year up into months, break each month up into days, and you're good. And what you get from that is a date, a local date. We call it in both Noda Time and in Java Time. Not sure about other frameworks. The use of local as a prefix confuses some people. And you're not going to remember this now live, but when you're watching this again in 6 months' time or whatever, this is an important bit to know. Local just means not associated with any time zone. It doesn't mean your local time zone to the computer that you're using, unlike, for example, datetimekind.local in .NET. So some people say that it should have been called global instead of local because it's not local to any one place. It's one of those things that's hard to name, unfortunately. But basically, it's a date. It's a date as anyone would think about it. So 19th of June, 1976, my date of my birth, that's a date in the Gregorian calendar. And some systems won't allow you to specify a calendar and just assume that you're using Gregorian. And for 99% of people, that's probably OK as well. But be aware of whether or not you can. Be aware at least, have your eyes open enough that you know there are other calendar systems. So once you've got a date, the next type is reasonably obvious, the next concept. A time of day. And this is just a time of day. This doesn't have a date associated with it. Examples of times that you might want a local time. My phone wakes me up at 6 o'clock. It doesn't wake me up at 6 o'clock Europe-London time. It wakes me up at 6 o'clock wherever I happen to be. That is a time of day, a local time. I think it's time for a little bit of trivia, and I'll scare you a little about the whole Julian-Gregorian cutover. So how many days are in February? 28. I hear a 28. Any advance on 28? 29. Shout. Shout. 29. Any advance on 29? Is there no one here from Sweden? Oh, or at least from Sweden in the 18th century. So in mostly the 18th century, all of Europe wanted to gradually change from the Julian system to the Gregorian system because the Gregorian system with its extra rules is a really good approximation for a full year as we go around the sun. It's better than the Julian thing. It's sort of like 22/7 is pretty good approximation for pi, and you make things more complicated and you get a better approximation. Likewise for how long it takes for a whole year. So all of Europe wanted to change from the Julian system to the Gregorian system. They all chose to do it at different times, but most places said, do you know what, we will just skip a certain number of days to get us onto the Gregorian calendar system. And Sweden decided that was too simple. They were going to, have people heard about leap second smearing at all? Yeah, so there's this idea of there are leap seconds, and so that's like a minute with 61 seconds in instead of 60 seconds, and they're unpredictable. They're announced about 6 months in advance due to the Earth wobble and complicated things. And rather than everyone have to build their software to cope with this, there's this idea of smearing the leap second. So instead of a clock that goes 58, 59, 60, 0, 1, 2, it just makes everything take a little bit longer. Well, Sweden sort of wanted to do this with the Julian-Gregorian cutover. So they said, do you know what, 1700, we will say that's not a leap year. And we just won't have leap years for the next 10 times that there would be leap years, or 9, I can't remember. And then by the end of that time, we won't have had to have any skips. We'll just have had a bunch of 28-day Februaries in a row. That sounds really simple. Unfortunately, they got distracted. So they had a non-leap year in 1700 when everyone else was having a leap year. And then they got into a war. So in 1704 and 1708, they should have been saying, right, no leap year, no leap year. Oh, I've gone and done a leap year again. So by this point, their plan was completely out of whack. So they decided, right, okay, let's just go back to being the Julian calendar. How can we do that? Let's have a double leap year in 1712. So February the 30th, 1712 is one of, I now believe there are 2 occurrences of February 30th. I think the Russian Revolution decided it would do its own calendar things as well, and they had a February 30th, but I don't know as much about that. If you think that, that Sweden is a bit odd for doing that, I'll tell you a bit about when the UK changed at the same time later on. Sweden eventually changed later in the 18th century, so they kept going as the Julian calendar for a while and then went into the Gregorian calendar. I believe that this actually did have a historical effect at one point where I think it was Russia and some other country were going to have a battle. And they'd sort of agreed what date it was going to be, but they didn't bother saying the calendar system. And so one army turned up over a week before the other. It's like the Mars rover all over again. Okay, back to more serious stuff. So we have local time. What do you get if you put a local date and a local time together? You get a local date time. And that's what most watches will show if they show a date. They won't bother telling you what time zone it is, and you adjust it, or at least old-fashioned watches, the kind I still wear, you have to adjust it accordingly if you're on a flight. That's really simple. Doesn't know about time zones. Okay, now we come to time zones, and this is where you might be thinking, this is where it gets painful. If you're precise in your thoughts, it's not too bad. So, a time zone is effectively a function from time or instant to your local time, local date time, and what you see is that when you spring forward, your local time jumps by an hour, and then when you fall back, it comes down by an hour. You could also draw this as another graph, which is mostly flat. So if you have the offset from UTC, and UTC is not strictly a time zone, but you can think of it as a time zone. Anyone who's saying, oh, UTC is not a time zone, they're being pedantic for the sake of it, you can just ignore them. Seriously, there may be some niche applications where it's worth thinking about UTC not as a time zone. But for the most part, it's fine. So it's just a 0 point. It happens to be the 0 point that the UK observes during wintertime at the moment, but it's just an arbitrary offset that everything else can be relative to. So instead of this diagonal graph, you could imagine a graph that's sort of horizontal, so the UK would be on 0 most of the time, and then would jump up to 1 in summertime, and then jump down to 0. Oslo would be 1 for most of the time, and then jump up to 2 for summertime, jump down to 1. One important thing to understand is that it's not always just a matter of jump an hour forward, an hour backward. Sometimes things can jump by more or less than an hour, and you might have, maybe Oslo decides, hey, this Brexit thing sounded like a good idea, we're going to join the UK time zone. If you don't laugh, you cry. So in that case, they could have a line that started off at 1, and then went up to 2, and then went down to 1, and then dropped down to 0. And went between 1 and 0. And this does happen in real life. Rules change, not just in terms of when things happen, but whole offsets change quite significantly. I'll give another bit of trivia example. Samoa. Ask anyone, next time you meet someone from Samoa, as I'm sure we always do, ask them what they were doing in 2011 on December the 30th. And whatever they say, you can say, you lie. They didn't do anything on December the 30th. Because the Samoa time zone went, you'll have to imagine that this is a really small scale, or big scale, I can never remember which way around it is. So they went something like minus 13, minus 13, minus 13, plus 11, plus 11, plus 11. It may have been something slightly different to that, but it was definitely a gap of 24 hours. At midnight, at the end of December 29th, 2011, in Samoa, it went from December the 29th to December the 31st. They just skipped the whole of December the 30th. So never assume that, that things only change by an hour. And also, never assume that daylight saving time is always positive or always an hour. And this has become very real quite recently, since I last gave this talk, I think. So this is the simple form, is just the offset, or the mapping from time to local time. Another way you can look at it is to consider a standard time notion and a savings. So, for example, the UK at the moment always has a standard time of 0 and has savings of 0 in the winter and 1 in the summer. Okay, and you add savings and standard together and you get what we call the wall offset, you know, the overall offset from UTC. Something like California would be -8 as the standard and then 1 as savings, and most places have 0 or 1 as savings depending on whether they're in summer or winter time. Ireland, at the moment, if you look at the legislation, and most of the IANA time zone database is based on legislation, IANA says that since, I think it's about 2005, I can check it later if anyone is interested, Ireland's standard time is +1, and its saving time is 0 or -1. They have winter saving time instead of summer saving time, if you see what I mean. And this, the assumption that daylight saving time is always positive, is so strong that Java at the moment is not accepting that change. They've got a sort of backward compatible version of the same data so that it will give always a positive daylight saving time. But try to avoid making assumptions like that. Nepal, for example, has its offset. Most people are aware that the UTC offset isn't always a whole number of hours. So India is always 5:30. 5.5 hours from UTC at the moment. Nepal is 5 3/4 hours. But they were considering introducing daylight saving time. They don't have DST at the moment, but they were considering introducing daylight savings of 1 1/4 hours. Well, it kind of makes sense. It means for half the year, you're on UTC +7, and that's probably quite easy to work out with other people. So try to avoid assumptions. What I haven't shown is the other aspect of a time zone, and the reason it's a zone is it's meant to be a region on the Earth where everyone observes the same local time always, including back historically. Okay, so if you look in the time zone database, you will find lots and lots and lots of time zones in America that people would now call just Central Time. And the reason is, you say, well, these two places are in the same time zone, aren't they? Well, they are now-ish, but if you look back in 1975 or whatever, they may have had different local times. So strictly speaking, they are different time zones. And quite how much energy you want to pay to put into that sort of depends on your application. If you need to know exactly when and where someone was born, it matters. There are plenty of people living today in time zones that were different when they were born and will, going forward, we expect to have always the same offset. Okay, time zones are by far the most complicated thing that we have looked at so far, but does it kind of make sense at the moment? Okay, I'll come back to sort of things not to say about time zones later on, but by the way, the pedant saying UTC isn't a time zone is precisely because of this zone part. It's not like there is a region on Earth that is defined to be UTC. Everywhere geographically has a time zone, and it may happen to coincide with with UTC all the time, but there's nowhere that is defined to be it's UTC. Okay, so fairly simply, if you have a date and time in a particular time zone, that is what I call a zoned date time. There's a tricky bit here. This particular zoned date time that I've shown is unambiguous and valid. If I had given, I don't know the dates and they don't matter too much, but sometime in October 2017, and I put 0130 on the watch, it would have been ambiguous because that local time would have happened twice, because that's what happens when you fall back in a daylight saving transition. So you go, 159:58, 159:59, 1 o'clock, bomb, 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 and so you go over the 130 twice, and you can see that on the graph. This is why this graph is a useful way of doing it, as well as the horizontal one. If you try to work out what instant in time is represented by a local date and time, you can see that all you need to do is go horizontally from, you take your local date time and you go horizontally and you say, oh, it happened then and then. If you try doing it from here, it didn't happen at all. 1:30 in the morning in sometime in March, whenever it was, wouldn't happen at all because we sprang forward. We went, 0:59:58, 0:59:59, 2 o'clock. And other countries would do different times. So that's where, internally, if you've got the idea of a date and time zone, you absolutely want to have something saying, well, if it's ambiguous, which one did I mean? Some libraries will do this by storing an instant in time and maybe a calendar system. Others will store the time zone and the local date and time and the UTC offset. And it's all equivalent. A lot of these things you can represent in multiple different ways. Time for the next reminder. Hopefully by now this is sinking in, if nothing else is. I don't care if nothing else is, so long as next time I'm here, people say, do you know what, I went away and studied that, and it made sense, and I was able to use it. That will be a win for me. Okay. Sometimes you don't have a time zone. What you have is an offset instead. Oh, ISO. ISO 8601 is this sort of format. And beware of people who say, oh, I'm storing something in UTC format. It's like, what do you mean? Because UTC isn't a format. Do you mean you've converted some other form into an instant, and you're representing that instant, and you're using a textual representation, which is ISO? Because at that point, you are formatting. If you're taking a value and representing it as text, that is formatting. So ISO 8601 is a format. UTC is not. So anytime anyone asks, says, let's store it in UTC format, ask them exactly what they mean. This is ISO 8601 format, and here, this bit is the zone indicator, according to ISO. This is not a time zone. They screwed up. This is an offset. Very, very different. If someone tells you this offset, you do not know, and say they've read this from their watch, and their watch is time zone aware, you do not know what the time will be 1 minute later, because an offset is not a time zone. There can be multiple time zones, all observing the same offset at the same instant, but a second later, they can have different offsets, because different countries do things at different times. Does that make sense? This can be useful. I mentioned before that an instant was a good way of representing a timestamp, so things like log entries. It can be useful to include an offset as well. It sort of depends whether something notionally happened at a place or not. So if you're recording people going through a gate somewhere, then that probably makes sense. You don't really care about the time zone there because you don't care what the local time was going to be 2 minutes later, but it might be interesting to know what the local time was when it actually occurred. And you also might want to know a total ordering across, the gate for the system over here and the gate for a system in a different country. So you want to be able to convert everything and view them as instants, but you also potentially want to know what the local date and time was. So that's one example of using offset date time. The other is, frankly, when it would be nicer to have time zone information, but we just don't. So this format is very, very common within protocols, headers and whatnot. And in fact, the zoned date time that we had before, I haven't said what the time zone is. In this case, from the IANA time zone database, it would be Europe/London. The Windows database, time zone database, uses bizarre IDs. It would be something like British Standard Time, and it would still say British Standard Time even if it were in June, when we would be using British Summer Time, because Windows time zone IDs suck, basically. But there is no, ISO has this nice text format for representing an offset date time, but there is nothing standardized for zoned dates and times. And that's partly because the IANA time zone database is as close to a standard time zone database as we have, but it's not really standardized in a formal way. There's no ISO specification for it. It's kind of a best effort from a lot of people. Okay. So I think now we've covered, ignoring offset dates and offset times and things, we've covered all the different ways that you could represent now. So you could have it as an instant, you could have it as an offset date time. You might want to ignore the time entirely and just have a local date. You might want to ignore the date entirely and just have a local time, 3:42 p.m. You might want to include the whole time zone, 3:42 p.m. in Europe/Oslo, with an offset of +1 just in case things happen. Sorry, +2 at the moment, etc. Period is a different kind of concept. Period is closer to duration, but much more complicated, because humans have got in and screwed things up, as always. So whereas a duration is between 2 points in time, and duration arithmetic is really, really simple. If you have a duration of 3 hours and a duration of 2 hours, and you add them together, that's 5 hours. And you could do that by also looking at intervals, and it would all work nicely. Duration arithmetic is simple. Period arithmetic really, really isn't. It's calendar arithmetic, and different people will have different ideas of right results. And that should make you nervous as programmers to start with. Okay? How do you find out if someone is 18 years old? You want to know whether they can vote in an election. And the law says they can vote if they're 18 years old. Okay? The election's on February the 28th. In a non-leap year, can someone who was born on February the 29th vote? Do they celebrate their birthday on February the 28th or March the 1st? It's like, that's a judgment call. You could say they can vote if their birthday plus 18 years is before or equal to the date. Or you could say, take the date and subtract 18 years, and that becomes your sort of cutoff point. And those two, both of which sound entirely reasonable, give you different answers. Yay! The good thing is, if you can persuade your product manager or your client or whoever it is that A, this is something they should really think about, that it doesn't have an obvious right answer, but B, that they need to give you the answer they want, once they've done that, it's actually reasonably simple, even if you've got a framework that only supports the kind of arithmetic you don't want. So I truncate. So Noda Time will, if you add 1 month to January 30th, it will give you February 29th. Other frameworks may give you March the 1st instead. And if you're aware of that as a possible pitfall, you can handle it. Okay? I promise you, you can handle it. And do you know how you can prove that you handle it? You write tests. I'll talk briefly about testing later on. That's all the concepts. Okay? Has everyone basically followed along with an occasional sort of, oh, time zones are difficult? Yeah? If you can understand those concepts, and if you can understand how that means that having date time offset, and time span as the only types available is not good enough. So how do I represent a time of day? Oh, I'll use a time span. What does that time span mean? Oh, it's the number of elapsed hours since midnight. Well, it's probably not really, because if there was a daylight saving transition, it could be 8 hours elapsed since midnight, but it's still 9 o'clock in the morning. So it's a sort of, oh, logical, if you ignore time zones, well, why don't we have a type for that? So we have lots of types in Noda Time. And I'd advise you to think in terms of lots of types, even if you can't represent them using, I'm a realist. I know that not everyone's going to start using Noda Time. If you have to use system.datetime, system.datetime offset, or whatever you've got in the language of your choice, you can still use these concepts and put a comment saying, you know, this is actually a zoned date time, and I will keep the time zone in a different field if I have to, etc. Put things in variable names. If you have system.datetime can be UTC or local or unspecified, where unspecified is the equivalent of local date time. Local is sort of the equivalent of zone date time with a time zone which is the local time zone, the system default time zone. And UTC date time is sort of equivalent to an instant-ish. But because they're all stored in one type, it gets a bit screwy. But if you give your variables names that say UTC in them, and you validate that things really are UTC, you can avoid an awful lot of problems. So, basically, there's something difficult that I want you to do next time you run into time zone and date time things at all. And that's, I really quite like you to think. Now, we're used to sort of saying, don't make me think. You know, a good API doesn't make me think, everything's just obvious. Well, no, not necessarily. Noda Time is specifically designed to make you think. It makes you make decisions because it can't make you make those decisions for you. The idea is you make the decision and we handle making it easy to represent that decision in code. So think about what you need to store. And in order to do so, think about where the data came from. So if someone says, I want to schedule a calendar event at 9 o'clock on June the 20th in New York, it's a really good idea to store that information. Okay, I'll come into, no, I think I've removed the slide saying what the myths are, but you will hear people saying, only ever store UTC. And that's okay in some cases, but it's not always the right thing. You can very rarely go wrong if you store the information you were given. So don't make stuff up and don't remove information. You can derive information. So if you store, oh, the user asked me to create an event representing New York, 9 o'clock in the morning in 2020. And you know what? I want to be able to compare events wherever they occur in the world so that I know which happens first. So I'll convert it to UTC as well, have an instant, and I'll store that alongside. But that's only derived data. Okay, I haven't lost anything. I haven't made anything up. I've just derived it. That's a good idea for storage. You should be aware, and I see various people trying to use Noda Time and doing far more than they need to, which is my fault for not making it clear what they could do. They convert from a local time to a zoned date time and back again, and back again, and back again. And sometimes you need to do conversions in order to arithmetic. But you need to be aware that every time you say, what is this local date time in this time zone, that can go wrong. Because it might be one of these skipped ones, it might be one of these ambiguous ones. So just like I strongly recommend that you don't do any more string conversions than you need to, don't do any more conversions between local and zoned than you need to. Be aware of different calendars and cultures. You probably only need the Gregorian calendar system, but it's worth being aware of. And choose good textual representations. Where, for anything that might be read by people in multiple different cultures, if your target is developers, ISO 8601 is your friend. That's this one. It's completely clear that the year comes first. Okay? Do not write, in this case it wouldn't be too bad, but do not write 10/1/2017, because we don't know whether that's January or October. Even if currently the only people who would read it are in the US, don't use the US format. Even if only currently people who are in Sweden or Norway or the UK will use it, don't use that format. For developers who are I think it's reasonable to expect developers to be able to understand this, use this format. For anyone else, try to make sure that you can get what their natural format is. Or maybe use a representation, as Jennifer was saying before in her talk, if you're going to arrange a calendar event with someone, say, Tuesday, June the 19th, 2019. And if you put that text in there, that's awful for machines to parse, okay? Anyone who designs a protocol, like Atom had an awful date representation in, don't use anything culture-specific in machine parsable text. But do use culture-specific things for people, because that's what they understand. People, machines, different things, okay? Think where your text is going. I do sometimes wonder whether it would be interesting to have a programming language that had two different string types. One is people string, and one is machine string. And it would always, you would get machine-readable, but probably also developer-readable strings this way, and people-readable strings this way. And finally, the tip, I hate datetime.now, slightly more than I hate datetime.utc now. Almost never use datetime.now. If for non.NET developers, that gives you the system local time. It's good if you're just writing something and you're printing out the current time on this machine, and you don't care about that value being represented anything more than the current session, but otherwise it's a bad idea. But having these static properties, they shouldn't be properties anyway, they should be methods because they're changing. But having them as static things just kills testability. Think of your database as a service, so you make it testable by putting an interface in and using dependency injection. The system time, the current time of the world, is a dependency. So have a clock representation. Noda Time has iClock, and it has a separate NuGet package of nodatime.testing with a fake clock. So you can say, I would like to see what my code will do on the Y2K thing. I mean, not so relevant now, but if people had had that 20 years ago, it could have helped. Who knows what will happen next? Be able to test what will happen in all kinds of different situations. If you find yourself having to change the system clock, there's something badly wrong. Right, so there are a few tricky bits to be aware of. You will sometimes have to deal with incomplete information. Suppose a user does say, I want to schedule a calendar event for 1:35 in the morning at a particular, on a particular day. You may not get to ask them, well, which of those did you mean? In particular, it would be quite odd if you asked them which of them it meant, and it's unambiguous. But it might become ambiguous. Just skipping to the last sort of pseudo bullet here. Time zone rules change a lot. So last year, I think there were about 10 different versions of the time zone database. This year, I think we're up to 2018E, and I'm sure there will be more to come. So back in, I think, 2005, the US changed their rules for when daylight saving time started and stopped. It will happen again. Probably in the US, it will happen again. For all my joking about Brexit, I wouldn't be entirely surprised if Brexit changed what the UK did. The UK has had some interesting changes. I said I'd come back to the Unix epoch. People will say the Unix epoch is when it was midnight in Greenwich in 1970. No, it was 1 o'clock in the morning, because we were observing BST at the time. And BST didn't stand for British Summer Time, it stood for British Standard Time, which was 1 hour ahead of UTC, but without any daylight savings, and we were on that for 3 years, from 1968 to 1971. And then we decided that was a bad idea, let's go back to what we consider normal. We've also had British double savings time, where it was 2 hours ahead. All kinds of interesting stuff. But the point is these things change. So if someone schedules that thing for 9 o'clock on, say, March 20th in New York, if you've converted that to UTC, you might be wrong by the time it happens. The user said 9 o'clock. Why did you then wake me up at 8 o'clock? Oh, because the time zone rules changed. I don't care. I said 9 o'clock in 2020. What if they'd said 1:30 in the morning on March the 20th in New York? It's like, OK, well, which 1:30 in the morning? Oh, it doesn't matter. They're both the same. There's only one of them because daylight saving time, it's not a transition. Well, it might be by the time you get to 2020. So sometimes you won't have that information, and you should decide. Do not let the system decide for you, because that's at best got a 50% chance of being right, whether you meant the earlier one or the later one. And it could be that it's skipped instead of ambiguous. So think about those things. If I don't have the information, however unlikely it may seem, what do I want to do? And I've mentioned working with poor frameworks. If you have to use Java Util Calendar and Java Util Time Zone and Java Util Date, you have my deep sympathies. Noda Time hasn't taken off to nearly the extent that Joda Time did. And that's because system.datetime is confusingly usable. It's quite easy to think that your time code is OK in .NET if you're using datetime, even if you're doing it wrong. Your code might be broken for 2 hours a year, and maybe you don't care about that too much. In Java, it's so hard to use Java Util Calendar and Java Util Date properly that just everyone knows it's awful. So as soon as Joda Time came along, it's like, yeah, I'll have some of that, please. So you may be stuck using poor frameworks, but you don't have to be stuck using poor concepts. You can think of the bigger concepts and represent all the bits without having to write your own framework, without having to do all kinds of stuff. Just be really, really clear in all your comments and documentation and all your names. I did have a gotcha after all. Skipping to recommendations. I hope you've got the idea by now that put some time in. I'm not expecting you to remember this, but everything I said made sense to you at the time, so it can make sense to you again when you've forgotten it later. Put lots of tests in, think, document, and we're going to say this together, OK? Because I'm a deep believer that if you say something, it will stick in your memory. Right, so ready? All of it just take away. So take away. Next time you work with date and time, take a few hours to grok it. Everything else is filler. Thank you very much. Next time, we'll smash the patriarchy.